So one of the key elements about this project, the focus of it, is the idea of being able to import an image and then use data off of that image, whether it be its color, its density in certain areas, to create other kinds of effects or glean useful data off of that image. And really it's multi-dimensional. You could be taking off it could be a heat map, and you could be using it to identify weak spots on a floor plan of heat loss. But in our case, we're going to use it for expressing architectural ideas in, I guess, different ways. So the first thing we have to master, just understand, is this idea of bringing digital image files into our Dynamo environment. And we do that by using the idea of telling it that we want to grab a file. We want to take that file, that path to the file, and make it a file that we can actually see as data, and then read data off of that as if it was an image. So what happens is it ends up being, it goes from a path to what ends up being a bitmap that we then import into a node that allows us to look at that pixel by pixel according to how we want to sample it. And then we take that data off, and if we look at specifically at what this data set is, it is 441 points, as listed down at the bottom there, of red, green, and blue information on color. And it's 441 because it is a matrix that we created down in this idea of the surface array, which we're feeding in as X and Y samples. And I'll get more into the surface array in just a second. So once we have that, what we would call RGB data, we feed that in because we don't really want to use the colors. We just want to look at them as black and white images. And we're just going to take just to simplify data and work with it for this project. So if we look at now the data, we put it into a color brightness, and we get these values that talk about how bright or dark the certain point is on that array. It's still 441 points, but now it's just a relatively easy to use number that we can make height or diameters of things and a whole host of other information. So, but obviously this image pixel and this data that comes off could be fed into a host of all kinds of other different concepts. Now, underlying this idea that we have an image, we have an idea that we also, when we're sampling that image, we want to sample it in a way that we can create and work with geometry. So in this case, I've created a simple array system. I've got an integer slider that allows us to have 40 points. I'm stepping by twos. This gives me a way of both spreading out over the image and then sampling over a larger, wider span. But this step could just be one, and this step up here could just be one. But this is just a little bit of an experimental extra function that I put in there. And you can see how I've done that in the code block, where I made the steps here, which come out to be 441, equal the amount of points that I have in the array. So now let's go ahead and look at what happens when we turn this function on, because we're actually building an array. So I'm going to just turn the preview on so you can see what's happening in the background here. So what we have is an array that's 40 by 40, stepping by 2, which means that it's really only a 20 by 20 array with an interval of 2 between them. And we then take that coordinate point, which is a 441 point array, and our list of different values, and then we can feed that into two kinds of analysis that we have here. So I'm actually going to stop the video here, and then we'll pick up with what happens after we've created that array. That'll make it a little more accessible for the video clips.